I just got a alert from YouTube saying we're live, and we'll be with you in a few seconds. We're live and in color. So when we start, it's going to be 1:15 here, but in YouTube land, it's going to be a few seconds after that. And it already was. Okay, so there you go. So sit down and be quiet. And those of you who are out there on the internet, I don't care. Just talk among yourselves. Good afternoon and welcome to the September Silicon Valley Fourth Interest Group meeting. And welcome. I'm Kevin Appert. I'm the program chairman. And today I'd like to go around the room and I'd like you to either tell me what you're going to present on fourth day, tell me you're going to think about what you're going to present on fourth day, or give me some idea of who I might get or what they might say on fourth day. And the reason is, you know, it's not quite the last minute, but I would like to have some idea, you know, in advance of the actual event, who's going to be speaking and what they're going to be talking about. Inquiring minds want to know. A couple of announcements about fourth day. The first is that Chuck Moore has said he will be here. With all the usual caveats about snowstorms and creeks rising and all that stuff that he didn't deign to mention, but you know, welcome to the world of normal things where stuff happens. Now, green arrays, yes, they're going to participate this year, but it may be by remote control. I don't think there will be actually any green arrays, folks. Ray won't be here? Apparently not. Did you? Short attention span, like really short. They'll be telepresent. Much like Sheldon from The Big Bang Theory when he was, you know, just a monitor rolling around. But travel is becoming outmoded in today's world, apparently. So we're going to try to have green arrays by remote control this year, and I welcome their participation, and I'm glad that they're taking responsibility for the afternoon, exclusive of the fireside chat. And who am I to say that it may have been better served in some other mode? So, before we get to that part, I wanted to point out this article that timed out, and I wanted to say, when you're presenting, you should do the PowerPoint option, you know, the presentation option, which turns all the timers off on modern computers. And most modern computers have this choice. So that was using Python and sockets to control instruments, which is kind of a cool thing. In other news, it's Otter Awareness Week, Sea Otter Awareness Week. So if you can't take the 2-hour trip down to Moss Landing to say hi to some otters, watch some YouTube videos or some darn thing. There are our distant second cousins. There are things that we have in common with them. They're tool users. They will take a rack and smash things and feel good about it, much like we can. And you know, for them, it's food preparation, so they get a tasty meal with it. So let's go start around the room. George, I already know what you're going to present.
Bravo.
You're going to give the chairman's welcome.
Predictably.
Okay then.
As it happens, by the way, Unless you have a schedule for rumors and gossip, there's some gossip up there.
Let's get back to that.
So you got Honor Awareness Week, and so as soon as you talk about the Estonia, we'll go.
I'm not going to talk about the Estonia, but this is the anniversary of the sinking of the Estonia. You can Google it.
I will have room.
Oh, we're supposed to have something.
You have no idea.
No idea.
All right, be that way. Hurt my feelings. That was Dennis. Okay, the first thing you need to do is say who you are, and then tell me about Fourth Day.
I'm Brad Nelson. I will either do something clever with the robot board, or I will present some sort of 64-bit fourth on Linux. Not sure which yet.
Ooh, wow. That sounds promising.
Hi, I'm Dave Jaffe, and as of now, I have no plans for presenting on Fourth Day.
Nor any suggestions for the feeble-minded program chairman.
I'm Don Golding, and I'll be talking about probably an hour talk on the software for the robot, and then maybe we have an hour workshop.
That is not going to happen on Fourth Day.
Okay.
Unfortunately, we'll give you as much time as we can. This project is very important to us, but with other people
Right.
coming from far distances, let's take advantage of their time. It may be that Green Arrays would be willing to give you some of their time in the afternoon, but don't count on.
I'll cut my talk to 30 minutes and then 30 minutes hands-on.
Well, the hands-on may be at lunchtime or offline in another room. We'll see what we can manage.
Or on day 2.
Yeah, well.
Yeah, day 2. It's my favorite day, the Fourth Day.
I'm John Harbold, and I don't have anything I can present on Fourth Day. Sorry.
You could give us a replay of last year's talk.
No, thank you.
Oh, you're no fun.
Oh, yes.
No suggestions either? No embedded systems interfaces or any of that stuff? You slacker. You don't need to stand.
I know, but my name is Curtis Schreier. I've been in almost all the Fourth Days, though I can't prove it by a photograph. If I knew more, I would do a presentation on telepresence. That's all I can say.
Hello, I am Andreas Wagner, and I may or may not get this done in time, but I'm hoping to present my sort of OCAD-like VLSI CAD tool with some simulation as well and other things, which I can't talk about yet. But if I can get that done in time, I may present that, yeah. May or may not.
Cool.
Okay, I'm C.H. Ting, and most likely I would still talking about force programming in our human being, in our cells.
All right. One thing I would like to repeat for those of you that already know it, because over and over again, it's just a broken record. How many of you, you're all old, so you understand what I mean by that? There's I'm a broken record, where you repeat the same thing over and over again. But these kids today, you all get off my lawn. So Strick, you going to present?
Yeah, I could give a lightning talk on my experience with a threaded interpreted spoken language I wrote once called Gerund that I used with Google Glass.
Oh, okay.
And many of you are still wondering about that.
I'm Sean, and even if I have something to say, no one's going to listen to me.
We promise to listen, except for the snoring noises.
That's what Bucky Fuller said. I seem to be a gerund.
Never met a gerund I didn't like. All right. So George was talking about rumors, gossip, all that stuff. I've got a new computer, new last month or two. It's just old enough so that I can't return it to the store. So let's see here. I had other things I wanted to blather about. There's an infinite supply. This is Hackaday. This particular article was this hackable ham radio multi-tool contributes to long-term survival of the ham radio hobby. So for those of you who are interested and don't know how to work Google, I don't know, you probably don't know how to use email either, so I'll tell you, send me an email and I'll send you a pointer to this Hackaday article about this ham radio multi-tool, which looks really cool and interesting and stuff. So, George, I am going to give you this and run away. And when you are done, I hope it's on.
Okay.
I have no way of knowing.
Is the brake on?
Because I can only talk or listen, one or the other. But Brad might have been listening to the audio just to prove it was working. So I need to use the restroom.
We'll see you very soon.
Blathering,
You
try
bet.
to keep it down to about 5 or 10 minutes. Give the mic to Don.
I'll take one
and
stroll
then
around
call
after.
it a day.
It's still working.
The polar route. We were talking about the Estonia earlier. Well, Estonia was a ferry, and stay off of ferries. Because the folks who run them, they don't run them into the ground. They seem to run them under the water.
Well, into the ground.
Yeah. Well, but the Titanic, fast polar route. Also, stay away from icebergs. Don't do the polar route. But earlier, we were talking about surprising purposing of technology. In the context of that, radio telescopy, the radio astronomy. I hear its first use was in the spy game, taking reflections off of the moon of radio emanations.
That was done by the radio telescope at Stanford.
Thank you. See, so much good stuff comes out of Stanford. See, and now we think of radio astronomy as like the search for extraterrestrial whatever and whatnot. How nice to go the purposing in the civilian direction. The Challenger. The idea was the force of the launch would drive the upper stage and the lower stage together and fasten the O-rings. But they also added goo, just to make sure, so to speak. But the goo was not certified at the temperatures run, and oh heavens. There's a story about the Roman chariots and the Challenger. And the idea that there's such a thing as junk DNA and they're discovering possible use of these junk, it's like we're looking for a Rosetta Stone. How do we know what these hieroglyphics are? Unfortunately for us, the Rosetta Stone was a gift to us from ourselves, and we're going to have to find this somehow in nature. Good luck to us. They fished some of those boosters for the shuttle out of the bay, and they had backup O-ring and another O-ring just for safety. And when they fished those boosters out, sometimes they found this first ring was burnt through. Well, good for us that we have 2 O-rings. Mission accomplished. So 2, 1, I remember 3 was the magic number. Hi, Don. Anyone have a rumor or a gossip? I'm going to there's probably all sorts of noise that comes from handling this thing like that.
Don Golding here. Work at Made in Space. Working on a really interesting new project. I was given the task of designing a new computer that's going to run the entire Argonaut 1 spacecraft, including a 6-degree of freedom arm. And we're doing this on an FPGA. We're going to put probably 2 RISC-V cores in it. And I'm going to do most of the coding in System Verilog. So I'm really looking forward to that. Been working on this board for how long? Yeah. So we finally have boards. We just got to make them work. So the status of it right now is the serial is USB serial is talking to the chip, it looks like to me. Brad is going to fix it, and Dr. Ting. Anyway, so in the Arduino, there's an incredible amount of setup configuration stuff. Now, this is using the ESP32 Solo module, which has Wi-Fi and Bluetooth built in. So this little robot is going to be able to, you're going to be able to talk to it over Wi-Fi or even your phone's Bluetooth. I found a kit on a motor kit anyway for a small robot on AliExpress. So anyway, some of the people in here might want to make their own, which is fine. I will be providing different bits and pieces of the full robot. I have a mechanical engineer at work that's going to help us make a little platform, you might say, for the motors to sit on and the board. I used to work for a battery company, and I got a case of some really nice lead acid batteries. They're 12 volt, 0.6 amp hour, so they'll be smaller, for $5 a battery, brand new batteries. So we'll have those. I found some 13.8 volt battery chargers that are specific to charging lead acid batteries, so I have those. So the kit of parts to make the complete robot would probably be about another $50 or so. You can buy, if you want to design your own, you can buy some pieces that you want. If you just want to buy the battery and the board from me, or just the board, whatever you want. So we have a lot of fourth programming horsepower here in Silicon Valley, and we're going to start working on designing the software, which we're going to take my original Whiskers Triune OS software, which is written in Maxforth in the day. It ran just fine on an 8 megahertz 8-bit processor. We now have a 32-bit processor with 400K of RAM. I don't know what we're going to do with all that RAM. Yeah. So anyway, the original, the complete operating system and the language fit in 64K. I'm sorry, it fit in 32K PROM on an 8-bit microprocessor. So this has enormous amount of flash on it too. So we can really increase the functionality of the language. I kind of designed the language to be very English-like. I tried to keep it English-like because I wanted to put a voice recognition front end on it. So you just take voice to text, which you have the board, right?
I have it, yeah.
Yeah. So we found a $50 voice to text board at the last Maker Faire, and we'll be able to take that and then put it right in the serial port, and you could actually talk to this guy. So that's a lot of stuff coming over the next year or so as we kind of unlock the power of this microprocessor. So right now we're going to go into a workshop and see if maybe we can get this board working. That's all I got.
One question. The board is 12 volts.
12 volts. Yeah, you can actually, it will probably run on 5 volts. I have a switching power supply on it, which means that and it's switching it down to 3.3 volts. So it will probably run down to 5 or 6 volts. So anything above 6 volts should run it. Yeah, it uses, the micro uses hardly any power. You know, it's using,
Does 5 volt work?
I believe 5 volt will work, yeah. You might want to put a voltmeter on the 3.3, just make sure it's 3.3.
Okay.
Any other questions?
Can you talk a little bit about the architecture and what processor it is, and why it is, and what verticals there are? And
Oh, sure.
stuff?
Okay. All right.
Is there a website repository for software, for project details, for schematics, for stuff?
Yeah, we should set up a Git. Do we have a GitHub for the group?
No.
Why don't we set up a GitHub and I can.
By we, when someone uses that word around here, that means you.
The royal we.
Yeah, the royal we.
Yeah, but I think
Brad is a good candidate to help you. Otherwise, call for volunteers and somebody might raise their hand. That was just an example. I wasn't volunteering.
All right. You got it.
I am reminded of a fourth universe celebrity who was once in charge of this fourth incorporated company who wanted a table moved. And this person stood in front of the room and I said, I need that table moved. I need 3 volunteers. You, and you. One of the persons she pointed at was me, and she had to find another volunteer, but that was a separate issue.
All right, so what's on the board?
As you're in question mode, still.
Okay, question mode.
A thought I had for the flashing pit. Have you made sure that all of your address lines to the flash
It's all in the module.
it's all on
Yeah,
the module?
this
The
is-
flash is on the module.
Yeah, so there's the only thing I have is I/O lines coming off the module board.
That answers the first question.
So it's a computer on a board that gets soldered onto my board.
If the flash is pre-debugged,
Yeah, it should not have any problems.
then you should be able to flash the whole thing.
Mhm.
What I was thinking is maybe there's an address problem and you're flashing over the same place every time.
Nope.
That would have the same type of behavior you see.
Yeah. So, that's actually a good question. So let's talk about this module right here. You notice this isn't a microprocessor. This is actually a little board. Okay, that gets soldered down to my board. It's surface mount style. It's smaller, and I like that. So what's on this basically it's a computer. It's a 32-bit computer. It has 400K of RAM.
4 megabytes of flash.
4 megabytes of flash. It's got Wi-Fi. It's got Bluetooth, and it's got serial lines, RX and TX. And we also I found we have to use CTS and RTS.
What's it
also.
called?
It's called an EPS32 Solo. So Solo 1. So, so that's quite a powerful processor for robotics. I mean, it's pretty amazing. We do have a flash card chip, so we have long-term memory storage. We have 4, you notice there's an LED right here. This is the robot's eyes. There's an LED photo Darlington pair here, 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 and here. So that way, when the robot's running around, if this eye sees something, it can back up and, you know, trigger a behavior or an instinct. It does have, these right here are the whiskers. One comes out there. I found that whiskers are super reliable. There's nothing more reliable than a switch. So, sensors with robotics, they all have their pluses and minuses. The optical sensors can see non-contact, but then they have a certain view field, right? Whiskers, when something touches a whisker, that's a very reliable sensor. So I kind of look at robot sensors as they're complementary. We also do have we have an H-bridge motor, dual H-bridge motor driver, which is the little FETs right here, and that's super efficient. We can do pulse width modulation, really fine motor control. Even though we're turning the motor on and off rapidly, it'll seem like it's very smooth. We have a microphone so the robot can hear, and that goes into an ADC. So with such a powerful processor, we can, at a minimum, we can do some sort of sound detection, like maybe you clap 3 times and the robot does something, or you clap once and it does something else. Maybe you whistle, huh?
Understanding fourth words?
Speech recognition, you can play with it. It's a 30.
Add-on.
Yeah, so it's just software, right? So you can work on the speech recognition component. He just volunteered.
I recognize.
You like how that works?
No, I don't.
Okay, so now I also put sonar. So these two little connectors here, there's actually piezoelectric sonar sensors. So the robot, I've experimented with these in the past, and you can see a good 20 feet away. So that means the robot, because now we could remote these and put it on a head that pans back and forth. I think I put 2 ports on there for servos. So you could have up to 2 servos, you know, one going left and right, one going up and down, and mount your sonar on that. It also has a speaker, and Dr. Ting has it playing Bach right now, I think it is. So the robot can come over and play your favorite tunes. In fact, you could download tunes from the internet. So, while it's running around. So because this board has access to the internet, I mean, your imagination is what limits what you can do with this board. I did do a little research. My interest is in AI. I don't like dumb robots. I like smart robots. So that's the whole reason I did this. And I'm making it open hardware, open source. So when we set up GitHub, everything will be up there. So in researching AI, I found on IBM's Watson, you can actually create an account for free, and you could have this little guy go talk to Watson. Pretty wild. There's a few other AI sites. I didn't explore AI. There's a lot of AI on processing, sites on the internet. So because this little guy has internet access, you could use any of those sites. We can explore them. Maybe it sees something and it kind of comes up with some sort of pattern, and then maybe it throws it up to Watson, and I don't know. It'll be fun to experiment with it. And I think that's and it has a USB serial port on it. And I did use a mini because they're much more robust than the micro USBs. I'm always buying, new cables for my phone, so I didn't want to use those, the micro. this connector here, we have some additional I/O stuff, I/O pins coming out we can play with. So that's what's on the board.
So some of these ESP32s have Bluetooth. Does this one?
Yes,
Do you have it brought out to an antenna?
it's all on the board. So what's nice about buying the SAW board
Yeah.
is it's already FCC certified, so I don't have to submit this to the FCC.
That's approved.
Yeah. So, like I said, it's got Wi-Fi and Bluetooth wireless on the board, including board antennas. That's under the black.
So coming soon is the iPhone Bluetooth app to talk to your...
We have another volunteer. Yeah, you work on the Bluetooth app.
We'll get Masa to do that.
I think that would be really cool to talk to this board over my phone's Bluetooth. I would love that. We could actually use it with the Wi-Fi that you've already demonstrated. Dr. Ting has already written the Wi-Fi, and
The
Brad.
problem with Wi-Fi is that if there's ever another Maker Faire,
Right.
it's a challenging environment for Wi-Fi.
Well, I think it's probably challenging for Bluetooth too.
Wait, what is the challenge?
There's too much of it there.
There are too many users. Oh, all right, okay, so it's not like, and you may not have the same trouble with Bluetooth, but you're not going to have much range.
Right. What, 10 feet?
You lose range at Maker Faire.
How much do you need?
Not much. For a demo,
3 feet is...
1 foot is fine.
Yeah, I think Bluetooth goes out to like 25, 30 feet, the spec.
Not at Maker Faire.
No, I'm talking, yeah, I'm beyond Maker Faire.
You'll get a couple feet at Maker Faire.
Right. But we're not going to, 99.999% of the time we use this robot, it won't be at Maker Faire. So, so we don't have to worry about it.
99.999 and as many nines as you want, because as near as I can tell, there ain't no more Maker Faire.
Oh, that's true.
Is that everybody else's?
Still call.
Andreas wants to say something.
They are thinking about bringing it back in a reduced form
Yeah.
and having Maker Media as a non-profit community thing. And
So-
having a smaller Maker
A
Faire.
red dwarf. Oh, were they trying to make money? Oh,
Maybe,
well, what do you mean by made? They made a lot of money. but they
Could have
couldn't
fooled
keep
me.
it.
So if we don't have a Maker Faire to go to, those of you who are interested in furthering cost and dragging people in, there's another activity that has nothing to do with Maker Faire or makers, but it is the Vintage Computer Fair or Festival or something beginning with F, run by the Vintage Computer Foundation or Friends or something beginning with F. It's all a TLA, which stands for three-letter acronym, or other things. But since we're an old established antique or bunch of antiques,
Respectable.
we could, sort of elbow our way into that and say, okay, here's our thing. It's useful for education and stuff, and it uses this antique computer language.
There you go.
And,
now be nice.
We'll just have like a picture of a coal-fired Babbage engine, and maybe we could have an online link to somebody's 1130 running 1130, IBM 1134th, and Don's robot.
I've got a Radio Shack color computer.
There you go. Does it run fourth?
Yes.
Okay, there you go. But what are we calling this thing besides the robot?
I actually thought of a different name. What the hell was
Okay,
it?
let's have a contest.
There you go.
I propose fourth bot, but you figure it out and send your emails to Brad or somebody. No, send your emails to Don. Send your emails to the
Email
list.
to the guy who wants
It-
that content.
Well, I think
I wasn't there. So it didn't happen.
I would propose a name with AI in it. So,
AI.
huh?
Failed. That is actually something I am working on at the moment. On the ESP32
Oh.
and the RISC-V chip. The fourth,
Both? Using RISC-V and an ESP32
Yeah.
on the same board?
yeah,
Interesting.
even the ESP32 is not quite up to doing classifier of an AI chip. And this RISC-V is optimized for doing convolution neural networks, which is a common form of neural networks.
Is this on a FPGA? Is it a core? Or is it a ASIC?
No, whether it's a core or they just made an ASIC. I don't know what they did to make the RISC-V chip. But what I have found, the two words you want to remember to do AI on something like an Arduino is OpenCV for computer vision. That is done on big computers. That's the one that does the training for doing machine learning. It's a very large system, and I'm starting to get it set up.
CV?
OpenCV.
OpenCV, okay.
OpenCV.
Check it out.
The other one is OpenMV, which is Open Machine Vision. That one runs on Arduinos. That one's just the classifier portion of a
Go over and stand next to him so that the mic is closer to his mouth.
Oh, I see.
Words are coming from.
You mean I'm not speaking loud enough?
You're speaking plenty loud.
But,
We appreciate that.
those two packages are how to get into neural networks on an Arduino class machine. And I don't know if I'm going to end up with a paper for fourth day. I don't know what I'll be able to talk about, but I'm setting up those two systems right now.
Can you send a link out to the group?
Sure. Okay.
Cool. That sounds wonderful.
Yeah. And there's a bunch of tutorials online on how to do it. It's like all Linux tutorials. Good luck.
Some healthy reading.
There's some healthy reading and redoing things. Put it this way, I tried to set up the OpenCV, got it so messed up that it will never work again. And so I ended up doing it in Docker, because now I can repeatedly recreate it easily. But yeah, it's that complex. But hopefully I'll be able to talk more about it as it goes on what we're doing.
Yeah, I am reading some healthy books on System Verilog. And I just got an advanced book. And I mean, they're doing, SHA and encryption and all kinds of they're doing pipeline multiply, pipeline multipliers.
Doing FPGA,
Yeah.
absolutely.
So, and it's got synthesizable source code in it. So I know I'm going to be needing it at work.
Yeah.
Yeah, so probably sometime within the next 12 months, I'll probably do something with an FPGA and the robot, maybe another board, or maybe a board that plugs into this board. Yeah, and put a RISC-V on it and maybe Vision or some crazy thing.
Vision tends to be the classic model right now because it's got probably the most research behind it other than audio. Audio has a lot of research behind it too, but not so much in the AI realm. The AI was audio you can do with sequential logic, but video you sort of need AI to do.
Yeah, so I was doing consulting for a monitor company. We're making our own industrial monitors, And the monitors, you know, their interface is LVDS. The cameras use a form of LVDS called MIPI. And MIPI is, so you have basically already a digital stream coming out of the sensor. FPGAs love digital streams of data and crunching on it. So we could do things like real-time thresholding, you know, to like look at an object. That's one of the things you do, you know, like to look at a doorway or something like that. So, yeah, we'll get into that a little bit later on once we get the robot up and running.
Right, exactly. Good.
Any other questions? Okay, well, that's all I got.
All right, so Brad, you going to help Dawn set up a repository? I think that, you know, just as a start, there are schematics, right, that you're willing to make available, and design information about the hardware, and skeletons of software stuff that will be accumulating apace. At the moment, most of this communication among participants is going to be on the email list. Who is not on the email list? Raise your hand. Okay. If you're out on the internet and you're raising your hand, go to the agenda page where there is an email list, email address. It's my email address. I'm Kevin Appert. That's me. If you search for the word Forther, F-O-R-T-H-E-R, on that page, there's my email address. Where's the agenda page, you ask? Well, go to your favorite search engine. Some of us use Google because we just don't care. Ask next SVFIG meeting, and that'll take you to the agenda. One of the choices is probably going to be the agenda page. So, leaving comments on the YouTube channel, not effective. Sorry. So send that email to me, and I will convey it to our email list administrator, manager, chairman, and great guy. If you are here and you want to get on the email list, the guy in the red shirt there, not him, the other guy in the red shirt, he will do that for you at
Break time.
At break time. And I guess my question is it too early for break for cake?
It depends on what's up.
All right.
Where's that agenda?
Any objections to break for cake? So in this case, the cake is the truth and the agenda page is the lie. So a motion to adjourn is always in order. It takes precedence. It's not debated. George is going to go get the cake. We're going to wake Dave because he likes cake. And we're going to take a break. We may not come back. So it just goes to show you.
We have all the tools here.
We'll come back for, yeah, well, we're going to be experimenting with a remote presenter. So I don't expect that it'll be, can't miss it, but
There'll be some test footage.
by 3 o'clock, we will be futzing around with that stuff. In the meantime, we may invite ad hoc talks, people introducing themselves. Nobody said their name at the once around the room exercise, so it just goes to show you. So we're going to take a brief hiatus and have some cake.
We're going to sign out and come back at some point when to test things with Greg, but this is the end of our regularly scheduled programming.